Given that rho equals x squared plus y squared over the lamina bounded by y equals x squared and x equals y squared, find the mass, the first moments, and the centroid, or in other words, the center of mass. Okay, so the mass is the double integral of the density. Okay, so if you sketch a region, I don't know if I have a region, I don't think I do. Okay, so if you sketch your region for this, just kind of do it real tiny here. Y equals x squared, of course, looks like that. And then x equals y squared looks like that. So you get, that's the region that we're integrating over. The bottom one is y equals x squared. The top one is y equals root x, right? And then this point of intersection, so this is 0, 0, this is 1, 1. Okay. So our mass is the integral from, I did dy dx. So y goes from x squared to root x goes from 0 to 1 of your, oh wait, that's my m sub y. Where's my mass? Okay, well anyway, let's pretend the x isn't there. X squared plus y squared, that would be mass. And then m sub y, you multiply this by x, m sub x, you multiply it by y, and then you divide it by the mass. So apparently I decided to find a moment's function. So I set it up and then I put it in my calculator. Today might be a fun day to use calculators, even though you don't get them for your test. But you got it for this problem, so if you could figure it out, that was great. So in this problem, since everything was symmetric, the density was symmetric, the region was symmetric, everything was symmetric, so your m sub x and m sub y actually end up being the same. Your mass, there's the mass, right there. And so then your center of mass is each of these divided. Remember, it's m sub y over mass, m sub x over mass. But you ended up getting around 0.627, 0.627. I'm kind of curious. Wow. You're right. So you have like a gorgeous exact answer on the back wall. Let me see if this is the same. So clear. So let's say 3024 over 1925. No, it can't be right because that's more than one. Something happened. Let's see. Let me check your math.
Maybe put the wrong thing over the wrong thing. So it should be the other
way. The math is right.
Should be the other way around. Do 1925 over 32.
1925 divided by 3024. That's it. Yep. Yeah, it's m sub x over m and m sub y over m, m sub x over m. So you guys nailed it. Well done. So 275 over 432 sounds like great. 275. Yeah, you guys got it too. Well done. Beautiful.
Yes, I got it.
Okay. See?
No, you mean he got it.
I thought you said that means I got it. But if you said that means I got it. Okay. Is that equivalent? Yeah. Is it? Really? Well done. Okay. And then, no, but you guys had, let's see. So your math is correct. So, something happened with your m sub x and m sub y. The setup looks good. So y
So you have to solve for, if you're doing y dx, the answer will be y equals x. And then you solve by plus.
You know what happened? You guys plugged in your x squared in here, and you should have x to the 6 over 2. x to the 8 over this one. That term, gotcha. This is right, this is right, this is right. So just plug your x squared into this thing right here.
This is the function.
So, yeah, so just have a little mistake. All right, good. How did you guys do? Not right? Do you know where your mistake was?
Oh yeah.
First one you got the same answer, but it's not right. You're right. I'm gonna pause recording for a second because. So for the second problem, the second problem's tricky. So, I don't think anyone got it because I don't see multiple integrals on any boards. So, did you have multiple integrals?
Well, he was working, and he got one of them, and I have the other one somewhere.
Okay. Okay, and then if you add them together, you think you got the answer?
Yeah.
Oh, perfect. Okay, well done. All right, so here's the thing. So find the volume in the first octant bounded by z equals 9 minus 4x squared minus y squared, y equals negative 3 halves x plus 3, and the planes x equals 0, y equals 0. Okay, be careful. The boundaries of the region in the xy plane do not form a simple triangle. Remember, your region needs all 4 boundaries. I shouldn't say remember, I should just say hint. Your region needs 4 boundaries because it's bounded by this guy, this guy, this guy, and this guy. And you might be thinking, but only these 3 are xy plane stuff, and this is some z floating above, except that this z is actually a paraboloid, and it comes down and intersects the xy plane, so it's part of the boundaries. So how do you know where this guy intersects the xy plane? Just set your z equal to 0, and then you've got your equation of it on the xy plane, right? So set your z equal to 0, you get y squared equals 9 minus 4x squared. So in the first quadrant, y equals positive square root of 9 minus 4x squared. So you have this graph. Come on. Okay. So you have this graph, and if I move it, I'm not gonna get my cute little arrow thing pointing. I'm gonna make it big anyway and see if I can line it up. There we go. Okay. Move this over just a tad. Move this over. There. Yeah, that's good enough. Okay. All right. So the red graph, that's the z graph, right? But it's flat on the xy plane. And then the black line, that's the y equals negative 3 halves x plus 3, or whatever the equation of the line was. And then, of course, the axes are your other boundaries. So the trick to this problem was recognizing that the region had like these different points that you had to take into account. So I did it top minus bottom. You could have done it right minus left. When you do top minus bottom, the only part that's tricky is knowing that this little like part right here is just, I pretend that's vertical, and it's just this little teeny tiny sliver that you have to add. So this is x equals 3 halves. How do I know that that's x equals 3 halves? Because if this is our z, we set z equal to 0, that's our y. If I want the x-intercept, then I set y equal to 0, and I solve, and I get x equals 3 halves. So I know that the red graph hits the x-axis at x equals 3 halves. I know that the black graph hits the x-axis. So set y equal to 0. How do I get 36 25ths? Let's see. Negative 3. Oh, it's not where it hits the x-axis. I need this little point of intersection, right? Yeah, that's what I'm looking for, is this guy right here. Okay, so to find that point of intersection, so you need to find where they equal each other. So you have, I gotta write this first. So you have this equation, and you have this equation, and you just set this equal to this, like set the y's equal to each other, solve for x, and do a little algebra, and you get 36/25. So anyway, so this little spot is x equals 36/25. So what do we end up with? We end up with an integral from 0 to 36/25 of the line minus the x-axis. And then you have this teeny little integral from 36/25 to 3/2 of your z function minus the x-axis. Right? Yeah. Anyway. So that was that one. Now you guys chose to do it horizontally.
Yeah, we did it right last one.
Yeah, you did it right. Well, that's how you drew your picture, right, Tindish?
I don't know what I did. Yeah, I
Right.
did top minus bottom, and I got x equals 18/25, but that's clearly wrong. We switched to dx dy. We started at dy.
And then you switched it.
Yeah.
Yeah, that's okay. It really, I don't know which way is easier. So, it might be easier to do it. It's easier to see, right? If you do it right minus left than it is to do top minus bottom. So you don't have that sliver. Then you just slice off and you get this kind of a rectangle with one curvy side and then a big triangle. The triangle, you just do geometry, right? Yeah.
If you don't mind, could you set it up using right minus left?
Sure. So, but now I need this y value, right? So if x equals 36/25, then my y value would be negative 3/2 times 36/25 plus 3. So I'll make that 18. Okay, so 354. So negative 54/25 plus 75/25. So 21/25 is my y value. So now I'm going this way. So let's say that y equals 21/25. Please tell me if I mess up my math somewhere. So now this that's gone. Okay. And so now what I would have is I would have an integral from 0 to 21/25, and then I'd have my x going from 0 to the z function solved for x. So if this is solved for x, so y squared minus 9 over negative 4, so 9 minus y squared over 4. So square root of 9 minus y squared over 4 of whatever my z is. Minus y squared dx dy. And then plus, and then for the triangle, you could just do a triangle, or you could go 21/25 to 3. And then my x's would go from 0 to, now the line, here's the line. So solve this for x. Y minus 3 times negative 2/3. So negative 2/3 times y minus 3, whatever, of your z function, dx dy. So, anyway, so that would be it left, right minus left. All right, let's get into a lesson. Since we just spent like 45 minutes on warm-up. 15.5, surface area. You'll like it. Okay, I know you might not care for moments and centers of mass at the moment. Get it? At the moment. But.
what a pun. What a pun.
But.
You just destroyed his mindset.
But honestly, they're not that gruelingly hard.
Yeah, they are.
It's just formulas, right? They're not terrible. They're formulas. They take a little work. They're not bad. Well, anyway, today it's just another formula. So, what I plan on doing today is we're going to walk through a few examples on surface area, and then what I'd like to do is take maybe 10 minutes and walk through any other homework questions that are driving you crazy, if there are any. So does anyone have any issues? Yes? Okay. So we'll walk through at least 1 or 2 homework questions, just to make sure you're comfortable, because I know I've been out a good bit. So, all right. So section 15.5, surface area. All right. I don't know if you guys remember arc length from last year, but the very first formula, we learned arc length in a couple ways. We learned it kind of a traditional formula, and then we learned it in parametric form. I don't know if you guys remember, but arc length was actually the integral of the speed. But it was the same thing as distance traveled in parametric. Okay, so anyway, arc length is the integral from a to b of 1 plus f prime squared. When we get this in 3 dimensions, so it's now the double integral over your region of the square root of 1 plus f sub x squared plus f sub y squared. So now it's like you're taking arc length, you're spreading it over the whole region, and you end up with these, adding all these z values together, you get this surface area of your region. Does everyone have this written down? No? Okay. Sophie, did I give you my cold?
I don't know. Someone gave me that
Someone gave you a cold? That's nice. It's the giving season. Okay. All right. Okay, write the integral that will give the area of the surface, 1 minus x squared plus y, that lies above the triangular region with vertices 1, 0, 0, 0, negative 1, 0, and 0, 1, 0. Use a calculator to evaluate the integral. So we're going to set it up, and then we're going to pull out the calculators and have some fun. We'll take a minute and do double integrals on the calculators, just for fun.
Oh, so
That'll be fun. That's the region that I got when I graphed.
So how do we know when we're supposed to like use the z value? Like
I think what you want is like, when do you know when the z?
How do you know if the z is going to cut it off into and get into your region?
yeah.
You can always set your z equal to 0, which you probably should, because there's at least one problem on your test with no hint and no warning where z cuts into your region. So how do you know if z is going to cut into your region? So if you set your z equal to 0 and solve for y, you get y equals x squared minus 1, right? Okay, x squared minus 1 is a parabola that goes through these 2 points and looks like that. Since our whole region is inside of this parabola, we're okay. If the parabola were to, if it was just like y equals x squared, then we'd be going, whoa, things are figured out. Well, yeah, I can't help you there. Because you're not going to have a calculator on the test, so you just gotta learn how to graph between now and 2 weeks from now. So, how did I graph the parabola? Oh, how did I get the parabola? So I just set my z. When you want to know where your z intersects the xy plane, just set your z equal to 0 and then solve for y. Yeah. Good. Other questions before we move on? Okay, so once you've got that, go ahead and personally, if I were doing this, I would do a dy dx. If you do a dx dy, you have to do multiple integrals. So I would do a dy dx. Go ahead and set up your double integral. So your outer bounds are x values going 0 to 1, but your y values have to be from boundary to boundary. So they're not constant. Right? So you're going to have to actually find the equation of this line and find the equation of this line. Check your setup. Don't worry about evaluating.
Points it goes through is 0, -4,
You guys need another minute? Okay, so to find the limits that give you this area, so since we're going dy dx, so our x values, the outer bounds, we're just going 0 to 1, right? Oops, whoa, stop. Go away. Stop it. I'm going to make this go away. There we go. Okay. All right, so our x's are going from 0 to 1. Our y's are going from this lower line to this upper line. So you actually have to find the equations of the lines. Well, they both have, like this has a slope of 1 and a y-intercept of -1, so this is just y equals x minus 1. Okay, I'm going to write that. Y equals x minus 1. And then this guy has a slope of -1 and a y-intercept of 1, so this is y equals -x plus 1, or 1 minus x. Does that make sense? So you're going... Okay, so our x is 0 to 1, our y's go x minus 1 to 1 minus x, the square root of 1 plus partial x squared plus partial y squared dy dx. All right, let's just have fun for 2 minutes. And try it on your calculator.
I mean, it locked, it wasn't locked.
Oh, let's polar first. So that's to get it into the battery compartment.
Oh, wait, no, it's in that. Oh,
No, okay, that's just the the case
I
kind.
thought it did.
Okay, before we get into another example, first I'm just telling you in polar is exactly the same thing. So you still have square root of 1 plus f sub x squared plus f sub y squared times r dr d theta or r d theta dr. But then you got to convert all of your f sub x's and y's to polars, to r cosine thetas and r sine thetas. So it's exactly the same, just with polar. But just remember, every single time you do a polar integral, you have that r dr d theta. Always multiplied by r. Your brain is mush? You've only got one problem.
I know.
Okay. Well, the warm-up was wrong. I know.
There was nothing in there to be.
All right, does everyone have polar written down?
No.
Oh, okay.
For every single scale.
Someone asked this morning, I'm not going to say who, but someone asked this morning, how do we know when we want to do find area using polar versus rectangular coordinates? If the problem says use polar, then you know to use polar. If it doesn't say, personally, anytime I see a problem that is easy to convert, like has x squared plus y squared all over the place, I automatically switch to polar. It's so much faster and easier than solving for y and having positive and negative roots everywhere. Blah. So I like polar if I see one that's super easy to convert, or if it tells me to use polar. That's the only time, like, apart from that, I just stand there. It really doesn't matter.
That R is not
The R is not under the root. Thank you for clarifying. Yes. I really should put the R in front. I just kind of like to say RDR. Good. Any other questions before we move on? You have this down? Okay. All right. So this is just a cut and paste of on the last screen. Here we go. Find the surface area of the paraboloid z equals 1 plus x squared plus y squared that lies above the unit circle. All right, so we have the unit circle. Excuse me. Pretty sure you all know what the unit circle graph looks like, right? Yes. Okay, good. So the paraboloid, if we set z equal to 0, we get x squared plus y squared. How does that even make sense? Equals -1, which means it never intersects the xy plane. It's just going to be up above, like the whole thing is opening up. So you have this paraboloid that is hovering, starting at on the pole at z equals 1 and just opens up from there. So you don't have to worry about it like cutting off any of your region because it never intersects the xy plane. Okay. So we want the surface area of the paraboloid z equals 1 plus x squared plus y squared that lies above the unit circle. I personally would do this in polar for a couple of reasons. So what I would love for you guys to do is just number 1, see if you can set up your double integral. Remember that when you do your f sub x and your f sub y, keep it x and y until you've done your partials, then convert to polar for your partials. To produce the unit circle, r is 1, and theta is going to go from what to what? 0 to 2 pi, right? Okay, so to find your integrand, you have partial x is 2x, partial y is 2y. So you end up with the square root of 1 plus 4x squared plus 4y squared. If you factor a 4 out, you get 4 times x squared plus y squared, which is just r squared. So you end up with an integrand of just 1 plus 4r squared times r dr d theta. So right here. Now, if you had to integrate this by hand, it's actually an easy integral. What method would you have to use? U sub. This would be a U sub, right? Not a crazy hard U sub. But see if you can do this on your calculator. Do you have to convert to polar? No, you can stay in whatever mode you're in. When you enter your double integral, you can even use R for R and theta for theta if you want to. It makes no difference. They don't care what they call it as long as if you put as long as you tell it what you're integrating with respect to. But you can just do, or you can use X and Y, it doesn't matter. Yes? Because R is not, don't confuse R with X. R is a radius from the pole. R is distance from pole. So our radius is 1 all the way around. Yes. Yes. So the 0 to 1 and the 0 to 2 pi. So to produce a circle centered at the origin in polar coordinates, your R is just the radius of the circle. It's 0 to whatever the radius, because I'm going from 0 to 1. Anywhere on this circle, my R is going to be from 0 to 1. Because it said the unit circle. Right? Circles are not always 1. And then to produce, so that gives you a radius, and then the theta says we want the whole circle, so we're going 0 to 2 pi. Going all the way around 1 time. Yeah, that's true. Well, no, actually, that's not. If you have one of those cosine theta circles that are off center, then it's only 0 to pi.
On top of the circle.
Ah. Did you get it on your calculator? You already know how to use it.
Simple math punch.
Makes sense. Yep. It's diamond or second. I can't remember. It's somewhere. Oh, there's just a theta button next to M. Yeah. Yeah. All right. Any other questions? So what I'd like to do for the rest of the time is go over some of the problems that we've been stumped on to kind of help make sure that we're feeling a little more comfortable. So I'm going to stop this. I got 5 root 5 minus 1 times pi 6. Yeah.